Mabuhay! I'm Xavier from the Philippines, and this is my entry to the Hong Kong International Science Olympiad mini experiment asking us how do theme parks control the flow of people in a systematic way. And today, I will show you exactly how they do that through a mini experiments. Let's begin!
Theme parks use different ways to control the flow of people, such as queuing. In this experiment, I made a mini model of a theoretical queuing set with marbles as our people and this as our attraction. Now my hypothesis is that the queuing will help guide the people to our attraction much easier than if there was no queuing in the first place. I will release the handful of marbles to people and see if this is true. 3, 2, 1, go! As you can see, this is true. Almost all of them went to the people. If not, some of them went via here to the railings. Now, let's try again. However, we do not have the railings or the queuing system in this scenario. Here we go. Time to repeat our experiment. 3, 2, 1, go! As you can see, only a few managed to reach our experiment. Only a few managed to reach our attraction here, which would be, as I counted, 3. Which means that, yes, my hypothesis is true. Queuing does in fact help guide our visitors to the attraction easier. For our second experiment, we have an architectural modification of the queue, that being the zigzag queue. While not exactly the best at efficiency and getting people to where they want to be the fastest, it can contain a lot more people than a normal queue and much more efficiently at that, leading to it reducing the amount of crowd density in a crowd and thus less bottleneck effects. And as you can see here, we already have some people raring to go for our star attraction. Let's see how they do against the zigzag queue. First, we're gonna move them through. Then, we already see one of them moving forward. And as you can see, they can easily and comfortably move in the queue with plenty of extra space. Even if this would be more than what our old queue could handle. And as you can see, some of them have already gotten to the star attraction. This proves that the zigzag queue, while not necessarily efficient, can in fact help reduce crowd density and thus acts as a crucial step for many amusement parks. For my third experiment, I will be doing stairs versus ramps. We have a handful of people here, which I've made white marbles so that you can see them easier. And basically my hypothesis is that while stairs do serve their own purpose, ramps are more inclusive and easier to use for everyone. So let's see. First off, we have the stairs, which as we can see, they do not provide as much stability as ramps in that the marbles can go in, the people can go in any direction they want and in some cases could fall off. Now, let's do the ramps. Ramps differ from stairs in that they are an inclined plane, which means that they are easier to navigate for those who are differently abled. This also means that, in our case of the marbles, they have a much easier time at accelerating the marble. In our next experiment, we'll be showing one-way versus two-way flow. In one-way flow, we have two opposite groups trying to go in opposite directions. This leads to a clog event, which means that both groups can't move in any of the directions they want and end up getting clogged. While in two-way flow, both groups have different ways to move, which means that they can move unimpeded. Now, I want to show you this using our marble experiment again, in which we have the marbles as a group of people and the one-way flow versus two-way flow. So, let's start showing by one-way flow. Here we go. So, for one-way flow, I will release the two of the marbles in different directions. So, like this. And as we can see, some marbles actually got stuck here in the center. Even though there were that many marbles on one side, some of them ended up getting stuck here on the railings because there was only one-way flow. While if I make a few architectural adjustments in which I prioritize the movement of both groups, we can end up with something like this, where both marbles can move easily without any impediment in their way. Just like that. For my last and final experiment, I will be showcasing the bottleneck effect. The bottleneck effect is similar to the clogging event that happened in the previous one, where I showed one-way versus two-way flow. However, this time, it only includes one group of our people. Now, basically, the bottleneck effect is caused by when there's too narrow a space to support the amount of people in a crowd, which can result in the flow of people getting stopped, and possibly, if there's too many people, people getting hurt or even dying. So, let me show you. So we have all of our crowd, and then we move them through, and most of them got stuck. And in fact, the only reason they were able to move forward is because I pushed them forward. In a usual crowd, there would be no singular push like that in order to free them. They would all be stuck like that in the center. What is the solution to this? Well, it's actually a really simple fix. We just need to make it so that it's less narrow, and there's actually space for our crowds to travel in. See, in this scenario, there's more than enough space for our crowds to travel in, and thus, we won't have to worry about a potential bottleneck effect. See, even if I move all of the beads at the same, all of the marbles at the same time, they still can't get stuck because there's plenty of space. And by that, I think we have found a solution to all of our problems.
See from our experiments, amusement parks or theme parks use a variety of ways in order to reduce the stress and hassle for everyone going. We can see this in how they use double roadways and how they use queues and other forms of ticketing or QR events in order to make the lines simpler and faster for everyone. That's it from me. I'm Xavier from the Philippines. Thank you for watching. Mabuhay!